Welcome to all. See, last class, that was around 10 days earlier, I uploaded. I clearly explained resolution when you have to resolve either along xx and yy, considering xx, yy horizontal vertical, or xx along the plane and yy perpendicular to the plane. That class is very important. You should go through it thoroughly, first of all. Now I will start friction problems for, you can write inclined planes. You can write heading here. Friction problems for inclined planes. See, consider a body, or rather block, placed freely on A, because it is not on, I first forgot A, okay, on a rough inclined plane, freely placed, which makes angle theta with horizontal as shown. See, this is the inclined plane. Inclined plane, see, which makes angle theta. This is a rough plane. Okay. Rough means there is coefficient of friction. Let mu be coefficient of friction for contact surface. This contact surface friction coefficient is mu. This all you know it. Okay, then. Now, I told, see, the word freely. I will explain something now. You should write after the class. Like, this is horizontal plane. I placed a block here. This is earlier cases. Now see, inclined plane. I will place a block, freely placed. See, you can see the block is still at rest. It is not sliding. Now see what happens now is, I will slowly increase the angle. See here. See, you can see here. At one particular angle, it started sliding down. I will explain that concept. See, when you place an object or a weight or block on an rough inclined plane, there is no need that it will slide. See here, this is horizontal. Slide inclined, see, it will stand. This way. I will give a practical example for you. Best example for you. Imagine a vehicle in neutral. You know what is neutral? Placed on an inclined plane. See, very small, an inclined plane. Maybe slightly inclined. See, imagine a vehicle. This all you are trying to understand correctly concept. See, imagine this is the inclined plane. See, small angle theta. Not big, very small. Okay. See, sufficient. This is the inclined plane. Vehicle is resting here. Four-wheeler, sufficient. See, small right here, theta, very small. Very small. Like, no brakes. Brakes are not applied. It is on neutral. Most probably, it will start sliding down. What is the reason? Because here, it is rolling friction, not sliding friction. A vehicle will roll very easily, so most probably it will start sliding down. Maybe for very small angle, it will be stationary. Even for a little bigger angle, see, even 10 degree also, it will start sliding down. Now, do one thing. You consider same vehicle here, see, some vehicle here, wheels are there, wheels no problem. Now, brakes applied. Okay, not either brakes applied or you put in first gear. Both are same. When you put in first gear or if you apply brakes, it will arrest the wheels. Wheel cannot roll. It has to slide. Now you can see the vehicle will not slide. It will not slide. See, even if the angle is more, see, even if it is like this also, now, if the brakes are applied or if the vehicle is on first gear, you know what is first gear? Then the wheels cannot rotate or roll. It has to slide. Sliding friction is always more than rolling friction. Rolling friction means very small. So that is, if it is rolling, it is very easy to move. See, suppose there is a vehicle parked on the road. Rolling friction. Wheels are there. Make it neutral. Push it. You can push it very, very easily. But if you apply the brakes, means wheels are arrested. Or if you put the vehicle in the first gear, means it will lock the wheels. Then when you apply a load, force, you cannot move. You require heavy force. Then it will not roll, it will slide. Sliding is always creates more friction. So this is a simple example for you. So now forget it. What we are discussing is, see, a block, either you call body or block of weight W placed on inclined plane theta. Don't see the angle how much, roughly angles. It is anything from zero, above 0, but within 90 degrees. Some angle, don't worry about the angle. Angle theta with horizontal. Now, what will happen here? See now, see correctly what will happen. This body has, see, this is the inclined plane. Inclined plane. This is theta. You should see what all I dictate, you have to write it. I cannot write on the board. Only in the notes I will write it. See, now this body has got weight. Okay, I will put the weight here to center. This weight is W, acting like this. Now, see, this weight W is acting like this. See, this is the weight W. Dotted line I will put here. W. Now, this W has got one component like this. You resolve along the inclined plane and perpendicular plane. See, one more component like this. How much component will vary later. So, this is the component, see, W, this is the component of along the plane. This is perpendicular to the plane, right here. This is component of W along the plane. Along the plane. This is component of W perpendicular to the plane. Now, make a note here. The component of the W perpendicular to the plane will press the surface, for which normal reaction will come. See, for which there will be, I will show red color now, a normal reaction will come here to oppose. But the force which is along the plane will try to slide it down. So, the force, the component, I am telling, it is freely placed, very important. The component of W along the plane will try to move or slide the body down the plane. I told you, will try. See, will try. Does not write here. He used the word try. Means it need not move. When it will move, I will tell you. Will try to move the slide tendency, or it has tendency to move the block along the plane. Now, when it try to move along the plane, see, there will be friction here. See, I'll put red color. There will be frictional force here, FF. It is not limiting now. See, right here. FF is the frictional force. Frictional force developed. Now, make a note. Why I put FF this way? Because tendency of this component along the plane is to slide the body down the plane. So, if friction is not there, it will easily, see, suppose you place on a smooth plane, it will slide. See, very smooth plane, it will easily slide. Why? No friction. So, when it tries to, when this component tries to move it down the plane, friction will opposite, it is up the plane. Now, see, all you are right. Now, right here, now, whether, see, these statements all, I told you earlier, in the class I am going to give statements, you have to write it. Only in the notes I will write all those things. Now, whether the body will really slide down the plane or it will remain stationary. See, whether the body will really slide down the plane or either slide or move down the plane or it will remain stationary depends on what is the frictional force. See, if the frictional force, if this component, I'll do one thing now, I'll give a name for here, W along the plane. Okay, I'll do one thing. This is W, some name required here. W actually, or I'll do one thing. If this is theta, see, this is 90 minus theta. 90 minus theta. This component will be W into sine theta. Why, I will tell you later. This will be W into cos theta. See, this W is making 90 minus theta with this plane. So along the plane component is W into cos of 90 minus theta. Cos of 90 minus theta is sine theta. Anyway, this I will explain later. Don't worry. Now you believe me. So now I told you this is a case of freely placed on a rough surface. Whether the body will, see now, whether the body will really slide down or move down or will remain stationary depends on whether W sine theta is more or less or equal to frictional force Ff. Frictional force Ff. Okay. W sine theta is more or less or equal later. Whether this W sine theta is more than frictional force or less than frictional force. Now you consider the case of limiting friction. See, now write one more sketch. Come to limiting friction. Limiting friction. So now you do one thing. Put the sketch once again and write Ff here. See, limiting friction is Ff limit. Ff limit. You know it, Ff limit. Limiting friction means the body is on the verge of moving down. Now, if the W sine theta, the component of W along the plane which will try to slide it down, if it is less than the limiting frictional force, see, if that W sine theta is less than Ff limit, Ff limit means limiting frictional force, I already told you 1000 times. It is the frictional force when the body is on the verge of moving or maximum possible static frictional force. So, if W sine theta is less than frictional force means friction limiting is more, the body will not move. Whereas if the W sine theta is exactly equal to Ff limit, see this all you have to write, Ff limit. The component W, see I told once again, freely placed, no other forces. If W sine theta is exactly equal to Ff limit, limiting frictional force, then the body is on the verge of moving down, moving or sliding down. And lastly, right here, if W sine theta, the force which will try to slide it down, if it is more than your Ff limit, means force which will try to move down is more, friction is lesser, then the body will move or slide, move down the plane. Okay, I will tell once again now for understanding. This weight is, I told once again, consider a weight W or block of weight W freely placed. See, no restriction, nothing, simply placed. See here, freely placed. See, freely placed. Now, see, I'll show it here now. See, now actually what happened is the component along the plane W sin theta is less than limiting friction. See, it is not moving. See now, one particular angle. See, you can see just started. Now your W sin theta is equal to FF limit on the verge of moving. But if it is more, see. So as theta increases, W sin theta will increase. You can make a note here. As theta increases, see, why it is W sin theta, why it is W cos theta, you wait for some time. I will explain. I will put a sketch and explain. Right now, you believe me. So, see, this W sin theta will increase with theta, but FF limit is constant. Why? FF limit equal to mu into normal reaction R. Normal reaction R will be equal to how much? Equal to W cos theta. W cos theta. Therefore, what will happen is, see, if the angle theta is lesser, then the force which will try to slide down is less than the limiting friction. Body will not slide down. If the angle theta is such that W sin theta, the force component which will try to move it down, is exactly equal to the limiting frictional force, FF limit, the body is on the verge of moving down. Whereas if W sin theta is more than the limiting frictional force, means more force this way, component is more. That is stiff angle. See, stiff angle. See now, see, no moving. See, on the verge of moving. Now see here. Then the body will start coming down or move down. Therefore, this is a basic part of simple theory. But remember, all these are when it is freely placed. Very, very important. Now, before I proceed further, I will give clarity. Now, today's class, I will limit to basic part of inclined frames. Here, inclined not frames, because I am doing actually some inclined frames in moment distribution method. That's why I told by mistake inclined frames. Okay, inclined planes. Sometimes it happens. Do a problem non-stop in structural analysis, inclined frames. Suddenly inclined means frame came from mind. Okay. Now, what I will do is explain the principle and some statement I will give now. And then I will give some clarification regarding line of action of that normal reaction. This I told you earlier. One puzzle also I asked. See, one puzzle I told. Then I told the reason for you. Normal reaction. How? See, if you remember, 1 minute, I will put a sketch and explain to you. So that today we will limit to some basic part of the inclined plane friction. Next time onwards, we will start regular questions. But concepts are important. I will rewrite all the principles now. Okay. Now I wrote neatly to understand, make a note. Case, see, first of all, make a note. This is the case when a body is freely resting. You should not touch the body. No force applied, no cable attached, nothing. See, freely placed. Like you go to an inclined plane, park your vehicle in the inclined plane, this way downside, and then apply the brakes. Okay, that's all. Apply the brakes or arrest the wheels so that rolling is not there, sliding is there. So, everywhere W is the weight. This angle is theta. So, right here, the force which is component of W along the plane, see, along the plane will be W into sine theta along the plane. Why W into sine theta? Actually, you can make out, see here, I will tell you why. See, okay, why that much confusion? See here, W is down this way. Okay, I put somewhere here, see, to understand. W, weight is always acting down. Inclined plane makes an angle theta. Theta. If this is theta, W makes this angle is 90 minus theta. Now, the component along this way and this way you require component. This component is W into, see, angle made by W with the plane is 90 minus theta. W cos 90 minus theta. See, because why? Component of the force along the axis or axis with which you measure the angle is 90 minus theta, is force into cos theta. But you know that cos of 90 minus theta is sin theta. That's why this is equal to W sin theta. This will be equal to W into cos theta. Okay, this is the explanation I given, remove it. Okay, now, see, case 1, you write here small angle, see, you write here small angle. Case 2, little bigger angle. Case 3, little higher angle, more and more stiff. See, very almost this way, no stiff. This is little stiff. This is fully stiff. This way, right here. See, all these 3 cases, W sin theta will have tendency, it may not succeed to move the block down the plane. Because why? See, this way, down the plane. But whether W sin theta force is successful in moving down or not depends upon whether W sin theta will overcome the friction, is it able to overcome the friction, or it is not able to overcome the friction. Which one? Limiting friction. See, everywhere comparison is limiting friction. Why? Limiting friction is always frictional force when the body is on the verge of moving. So, when W sin theta is less than frictional force limit, see, why I am not putting FF limit? Because this FF will be less than FF limit. That you don't bother. So, if W sin theta, which tries to move down, if it is less than the limiting frictional force, then body will not move. See, body will not slide down. It will remain in the position where it is placed, or it will be at rest. It will be at rest or in equilibrium. Nothing. It will stand. See, you apply the brakes on a little smaller angle, apply the brakes and go. Come after 1 hour. Your vehicle will be there only. It won't move. Problem comes, see, sometimes when people don't properly apply the brakes. Suppose the brake is released, then when they come back, vehicle will not be there. Police will be there in city. Who is the owner of this vehicle? See, the vehicle went there and hit somebody else. So therefore, here W sin theta, which is responsible for moving down, if it is less than the limiting friction, see, FF limit is always equal to mu into R. See, equal to mu into R. Okay, if it is less than the limiting friction, body will not move, it will be at rest. Case 2, W sin theta, which is the force responsible to slide it down. I am again telling freely placed. W sin theta, which is responsible, little parallel to this plane, see, it should be little parallel, okay. W sin theta, the component of the weight which is responsible or which will try to move it down the plane, if it is exactly equal to limiting frictional force, means body is on the verge of sliding down. It will not move, but it is on the verge of sliding down. Later, we will prove that, see, later, that is in next class. next class, we will prove that this theta equal to phi. Phi is angle of friction. Angle of friction. That is phi equal to tan inverse mu. This will be in the next class. It's an important bookwork. A term called angle of repose also will come. I will explain a term called angle of repose at that time, which you heard maximum you are hearing in soil mechanics. It will come here also. Okay. So this you right now you study up to here only. This is a note. Next class will prove that this is the case when theta equal to phi. Phi is angle of friction. Okay. Now, case 3, W sin theta, the force which is responsible to move it down is more than limiting frictional force. Oh, then tendency to move is more, resistance is lesser, the body will slide down the plane. But then, that is W sin theta is more than FF limit, then it is not static friction, it will become dynamic friction. In that case, it will become dynamic friction. Dynamic friction. Okay. These three concepts correctly understand now. Okay, now observe one thing. See, normal reaction I have put here. I will explain the concept of actually you simply in all the questions next time onwards, we will not bother. We will show normal reaction like this. Whether it comes little this side or that side does not matter because we are not going to take moment. We are not applying sigma m equal to 0. Therefore, you need not bother too much. Is the normal reaction little this side or that side? No, normal reaction, that's all. I will but explain now for you, for those who are interested in the concept, I will explain now regarding line of action of that normal reaction. Normal reaction. I will explain now and then close the class today. Next class we will do non-stop. Next class onwards marathon questions. Okay. See, actually, first of all make a note for ordinary students or those who do not want too much of high level thinking all, they want to understand the subject either for academic purpose or competitive examination, understanding this much is sufficient. What I am going to tell now, next round, is meant only for those. Some people will tell, sir, normal reaction, sir, how you put that side? That answer. I will tell something then. How, because every class what you can do is, you cannot, every class, no. I will tell what is that one. Not possible. Because we will simply put normal reaction R. But now I will explain little concept for normal reaction only for those who are very much interested in knowing the basic concept. Briefly I will explain. As I told you, this is only for those who are interested in concept. I will tell you one thing. See, I am very much particular about the concept. Today, if I got this much knowledge, not in engineering mechanics, strength of material, structure analysis, RCC, steel, or any pre-stress concrete, matrix method, finite element method, or any subject, it is all because of understanding the basic without any doubt. Doubt should never come. See, I always go for full clarity. Clarity to myself. I should know. See, when I teach, if I myself have doubt, what I can teach. So, therefore, understanding the basics is very powerful. See, even all these small basic concepts, what I am telling now, if you understand, it will help you to develop a very strong concept in structural engineering. Okay, see now. See, I will explain today about normal. See, I told you this is regarding line of action of normal reaction R. You should write it. Line of action of normal reaction R. If you remember, see, I will tell you one thing little earlier. See, if you place a horizontal plane here, see, suppose you apply a force here, this is the weight W, frictional force will be like this. If you try to move right side or tendency to move right side, if you remember, I shift the normal reaction slightly this side. Reason I told you, which side body moves, it will shift slightly that side. Whereas, in case you apply a force this way, see, weight here. Now, friction force will come this way. Now, the normal reaction will slightly shift left side. Yeah, normal reaction R. I told the reason, I asked a puzzle and then I told the reason for this one. But one thing, then I told, when you solve the question, simply mark R, don't bother too much. Because line of action of R, we are not interested. It is required only if you consider sigma m. Sigma m you are not applying for these cases. Because by applying sigma m, you cannot find any unknown. Sigma m will tell you where is the line of action. So no use for us. So therefore, this I told earlier. Same way here, for inclined plane, see, consider the case of body either sliding down, see, either sliding down. That is, you suppose imagine the case of body, see, either sliding down or on the verge of sliding down, or either it is sliding down or on the verge of sliding down, or it is not moving but tendency is to slide down. Then friction will be like this. See, what you do is, this is centroid, center of gravity of the block. See, normal reaction. See now, take moment about this point. See, W into 0. Frictional force Ff into this distance is anti-clockwise. To balance anti-clockwise moment, you require a clockwise moment. So, to create a clockwise moment, R will be this side, see, this side, see here. Now, Ff into this distance is anti-clockwise, R into this distance is clockwise. Or, if the body is either is sliding down or on the verge of sliding down or tendency is to slide down, in the question you can make out, normal reaction or line of action will be slightly downside. Okay. Then, little later we will knowing, consider the case when the body is moving up the plane or on the verge of moving up or tendency is to move up the plane. This will come, see, make a note, not free. When you apply a force, see, suppose a vehicle is parked here, you want to move the vehicle up, you require more effort, see, this way. That case will come later. Suppose, see, friction is now, here friction is this way. Why? Body is sliding down, friction is up. This is this way. Here, body is trying to move up. When body is trying to move up the plane, friction is opposite, down. Now, see, this, here, see, you can break freely. If you want to move up the plane, you either apply a force this way or apply a force this way. This all will come later. Then, take moment about this point. See, Ff into this distance clockwise. If the force applied here, once again, that force also is clockwise. Or these forces along the plane will create clockwise moment. If it is a clockwise moment, normal reaction R about this point should produce anti-clockwise. So it will slightly shift this side. See, this, see here, here, frictional force is this way, and frictional force will produce anti-clockwise moment. Normal reaction will produce clockwise moment. So it is this side. Here, frictional force is this way. So it will produce clockwise moment. Normal reaction R should be anti-clockwise. Or same as I told earlier, see, if the force applied this way, if the tendency is to move right side, normal reaction will shift that side, more pressure on that side, where it will shift that side. Whereas, if the force applied is this way, if you try to move this side, then normal reaction will slightly shift this side. Same way here. Whenever you consider body sliding down, normal reaction will be always on that side, which side the body is moving. So, when it is moving down, normal reaction will be little downside. See here. When it is moving up, normal reaction will be little upper side. Okay, now, this is the concept behind it. Okay, but coming up now, what coming up now is, I will tell you. See, this all for understanding. What coming up now is, see. Make a note. First of all, sigma m equal to 0, we are not applying for these cases. If by applying sigma m 0, you cannot find any unknown reaction. You can only, by sigma m 0, you can only decide line of action of normal reaction R. So, but we are applying what? Sigma fx 0 and sigma fy 0, equilibrium conditions. That is only forces. Only forces. In such cases, right here, it does not matter whether, see, whether you put R this side, see, one plot, see here. Whether you put R this side or this side, whatever way you put, see here. This is actually what? Whether you put R this side or this side, it is perpendicular to the plane. See, when you make sigma fy 0, it is this way. Here also this way, here also this way. So it does not matter, or no point in wasting too much of time. See, when a question on friction is there, weight acting down, W, normal reaction will be, see, if I project here perpendicular, this side or that side, friction is going this way, means it will create anti-clockwise. So you require clockwise moment. Oh, normal reaction here. Or, see, if it is sliding down, or if it is moving up, see here. If it is moving up by applying a force, friction is like this. Weight W is acting here. Now if I take moment here, this will create a this also will create a clockwise moment. So for balancing, you require anti-clockwise moment. So what I do, if I project here, normal reaction is here. So here, little left side of this projected point here, left side, little right side. What we will do is right here. When you solve the question, I will always try to write correctly, but you don't bother. What you do in future, what you do in future is, it does not matter for solving problem. Principle required. So what you will do is, see, right here, any question, weight W, then other things, friction all you write, normal reaction, see here. Right this way. Let it be slightly to right of this center of gravity or left of center of gravity. Does not matter. Simply show, because when you resolve, it is R. Whether right here or right here or right here, it is R only. Moment we are not taking. So make this concept. But since I go for perfection, I told the reason. Okay, that's all. So next time onwards, I will not waste time explaining why I am shifting normal reaction slightly that side or this side. I will not explain. It does not matter. It matters for those who want a thorough concept. They will understand by this concept. Okay, that's all. Today's class I will conclude. After around nearly 10-11 days I am uploading. I was little busy with other things. Little busy, so I could not upload any classes. Moreover, for 4-5 days night time, daily rain was there. If it is raining here, sound will come here. I cannot record. So now I will once again start now and continuously classes will come. Usually, see, you have seen earlier, I upload the classes daily, maybe rarely 1 day gap. This 8, 9 days or 10 days gap, I will not make now. Continuously, I will upload. Okay, now next class will continue. Thank you. We will meet in the next class.